No.
If I do a cool dance, can I get a jolly Rancher?
Yeah, you guys are gonna have to deal with it. Sorry. You'll get over it in a minute. Okay. Look at this function. This guy is a regular piecewise function. There are two different parts to piecewise functions we looked at yesterday. There's this key thing over here, and then there's the actual graph that we're going to use over here. The first part of the piecewise function is negative x. In your mind, you're thinking of y equals mx plus b. And if I set that up in slope-intercept form, I could figure out a few things about this. What is the slope of this graph? It's -1. Put slope, or m, equals -1. What is the y-intercept of this graph? Is there a value for b? No, it's just what, Hayden? What's the y-intercept? What's the value of b? There's none, so it would be? It's 0. So with that knowledge, you can start graphing. Start at 0, and we know it goes down 1 and over 1. Start at 0, down 1 over 1. That means it'd go up 1 over 1. Here's the difference with piecewise functions. Don't actually graph it yet. Don't go ahead of me, because this is the trick. You have x as less than 0. So if it's less than, you are going to end up putting an open circle. If Pac-Man has a chin, fill the circle in. If Pac-Man doesn't have a chin, you leave it opened. So let's leave that circle opened. And then it's going only one direction. All of the x values are less than 0. So am I going to have a point over here? Don't write this. The slope goes down 1 over 1. Am I putting any points over there? No, because the x values are greater than 0. I want one that is less than 0. So instead of going on the right, we're going to put all the points to the left. Up 1 over 1, that point works. Up 1 over 1, that point works. Up 1 over 1, that point works. This is your piecewise function. It is not a linear equation. It is different. It has a ray, not a line. If that blows your mind and just is like making you confused, this is your new introduction to this. You'll get more at it in Algebra 1 or Algebra 2. But this is how you graph that first part. Hayden.
So did you know that the slope was -1 because it says -x?
There was a 1 in front of the x. We use that knowledge. And then -1 would be the slope. Yep. Pause before we move on to x plus 1. Why would this graph use rays? And actually, no. Let's go ahead and do x plus 1. So this will make it a little clearer. If I focus on this guy, x plus 1, and I want to set up it in slope-intercept form. What is the slope of this linear equation? Caden, what do you think? What number would go in place of m? Is there a negative in front of here? It's just +1. You can always put a 1 in front of x. You don't need to. Algebraically, they'll kind of leave it as an x. What's the y-intercept, Charles? Look at the b value for our second equation. It's 1. So put a 1. Hey, I found your test. Yeah, I have to grade it. Remind me tomorrow. So use this information, go back to slope-intercept land from 8th grade, and let's graph this one. But look at your rule. What do the x values have to be greater than, Kaylee? And they're not just greater than, they're greater than or what? Equal to. That line tells you Pac-Man has a chin. What type of circle do you think I use? Whole class. A filled in circle. If Pac-Man's got a chin, fill the circle in. So let's go to our y-intercept. We said it crossed at 1, right, Charles? Okay, let's put the y-intercept there. And it is going up 1 over 1. Does it go anywhere less than 0? No, it has to go in this part. Up 1 over 1, make a dot. Up 1 over 1, make a dot. Up 1 over 1, make a dot. Fill in the line. I'll pass out rulers when you start independent work. Just do your best for notes. That should be it right there. Yeah. Okay. It looks crazy. This is not a linear equation anymore. This is a piecewise function. Why am I using rays? I don't have this line that you're used to. All of your lives up until now, you have drawn something like that, and the lines go on forever and ever and ever, and they're never getting back together. That would be it if you're doing systems. Why am I using rays? Think about it. Think about why I'm using rays. Jot down a note to yourself. Why would I use a ray? I'm going to give you a hint before you turn and talk. Look, remember functions when we did the vertical line test? If I do a vertical line test like that, does it cross more than 1 point? Think about it. Think about having a chin versus not having a chin, being less than or equal to or greater than. Talk to your partner, brainstorm ideas. 1 minute, go. What do you think? What do you think?
It doesn't go down below the point where it's
It doesn't actually include this point, right?
yeah,
A point can't be 0, 0.
it doesn't go below the
Mm-hmm. Greater than or equal to 0. Zero. All right, 3, 2, 1. Let's get thoughts. Raise your hand if you have an idea to start us off. Here's your thought. When you have a function like this type of thing, and remember back in 8th grade or 7th grade for you guys, we did this thing called the vertical line test. And for it to be a function, it couldn't cross more than 1 point. Let's make it purple. Does that cross more than 1 point on this function I just made up? Yeah, it does. It crosses at the top and at the bottom. This thing isn't a function, okay? What if I do this? Does it cross more than 1 point? No. Why not, Stan? This is an open circle, which means it doesn't actually include this point. This is still a function. F of x means you're graphing a function. You cannot have this circle be closed and this circle be closed, otherwise it wouldn't be a function. This has to be opened, and that's why we have these weird little less than or greater than equal to signs. Be really careful when you see these. So why do we use rays and not lines? Your answer should be something like this. Because you need, or you can't have two y values with the same x. Hello? He is. Deacon had the J25 with your stuff. You'll watch this video later. Two y values with the same x. Okay, question, Elia.
Why is only the first point on the first equation an open circle and on the
Let's check. It'll be a little bit different depending on what piecewise function you have. But if we put in a 0, this is 0 where it's opened, right? So let's just say x is 0, y is 0. Let's plug it in. So negative 0 would become 0. Is 0 matching your rule for that function? Is 0 less than 0? It doesn't work. So you can't have this filled in. It doesn't work for the function. It cannot be 0. That's why it's an open circle. The moment it gets closed, it means you could have 0, 0 be a point in this function, and it doesn't work. Stan. I'm going to pause you. Example 2, graphing greatest integer functions. Do I want to do this one? Yeah, sure. Maybe I want to just get this. A greatest integer function is a piecewise function whose rule is denoted by this sign. There's a little like leg at the end. It looks like brackets or parentheses. It's slightly different. We want to graph this thing. Make a table for yourself. Erase what I just put. You don't want a line. And we're going to make this top the x and the other one y or f of x. When you're choosing your values for the x, you have to have a table for greatest integer functions, and here's why. You're going to basically be changing the x value depending on what it is. So let's put a -3 in for x. And remember, when you have a -3 inside of a greatest integer function, you always round which way? Always round down. Add that next to the greatest integer function. And -3 would just round down to -3. That's all you're going to put. So when x is -3, 1, 2, 3. The y is -3, 1, 2, 3. Make a dot. When x is -2.1, what is the y value? Emma. We're just making up points for x. I should have had this table on your paper, but I didn't. So we're just going to make any points for x that we want to, just like we could have made any points for this that we wanted to. F of x, we could have graphed the points like -2, and it would have given us 2. Okay, so you can make up any points right now, and we're just going to see what it looks like.
So we're picking for -3 and -3 to be the same. We can always change that.
Negative, you could have started with -4, and round down it would be -4, right? -2.1 is what we're going to look at now because I want you to see what it appears as on the graph. What would you round down to on your greatest integer function? Kendall? Yeah. Go down to -2.1, and it's going down to -3. There's a dot. Because you're rounding down. Always round down. This is Stan and Adam. Thanks for explaining this, Stan. This was a blunder yesterday on a lot of our papers. So if you have -2, -1, and 0, if you start at -2.1, round down on the number line, it's going to end up at -3. So you're always rounding down. It looks like you're rounding up, like to 1, but it's actually down. Don't make that. No. That was a blunder that like half of us had yesterday, so it's not just for one person. There's this thing going on. Notice what happened to it. It's just a straight line. Like it's not actually doing anything. Let's check out what it looks like when we do a -2. Plug in a -2 and round down, you get -2. Go over 2, go down 2, make a dot. We can't have -2 be -3. So we're going to include an open circle here and connect the dots. -2 isn't going to have a closed circle when you hit -3. Go to -1.3. Round down, it would be -2. Are you noticing a pattern right now? Go over -1.3, go down 2, make a dot. It's on this same line. What happens when you hit -1? Round down, Emma, to what? Okay. -1, go down to -1. Well, that one's a closed circle because it included it. But when you get down to -1, 2, where this part is, it can't be a closed circle. So you're going to make an open circle here. Okay, hang with me. From this point, we don't have to do any other tables. Watch what happens. When you have a 0, you can make a line and go over to 1. Open circle. Go over 1, up 1. Make a closed circle. Go over, make an open circle. Go over 2, up 2. Closed circle. Go over, open circle. 3, 3. Closed, over, open. Stand. You're not going to have to do this if you don't do... You actually probably will, because you're going to get into engineering. So yeah, look it up. I know that piecewise functions are for analyzing like different moving parts, as in like roller coaster design. If you want to get into that type of engineering where you're working on like any type of vehicle or any type of moving part, this would come in play. This is also called, greatest integer functions are called step functions. You kind of see why, because they look like a step ladder. You're going over and you're moving up 1. You cannot have any parts go in between. They're only whole numbers. Julia?
How do you know what circle is open and what circle?
It's always going to be the right circle is open, left circle is closed. That's a pattern you'll see across all piecewise functions that have greatest integers. Okay. That's your intro to it. I'm not going to dive too much into it because it is pretty confusing. I want to focus more on what we did in example 1. You're going to work with your partner right now. Just stick with your elbow partner. If you don't have one, you can turn to the person behind you. Work on partner work A. Yeah. You could have a -1 if it looks like this. If it says f of x equals -x, it'll flip.
That what flips out like the solid and fluid?
No.